Hello, Rohit sir.
Yes, sir.
Am I audible?
Yes, yes.
Our today's speaker, Dr. Jayaprakash Rahil sir, joined us. Please help him. Very warm welcome, sir. Are you hear me? सर को कॉस्ट बनाइए प्लीज करिए. सर प्लीज अनम्यूट योर सेल्फ.
Yeah, I'm trying to open my video. Yeah. Am I visible?
Yes, sir.
Is
Yes,
my
sir.
voice reaching you?
Sir. Yes, sir. Very warm welcome, sir.
Thank you. Thank you.
Sir,
Just a second.
within
Just a
5
second.
minutes we will start.
Yeah, definitely.
तब तक सर आप mind?
Hello, sir.
Yeah.
Yeah, sir,
रोहित
तब
सर
तक
प्लीज असिस्ट.
yes, yes, yes. सर तब तक पीपीटी शेयर
Okay.
कर लेते हैं जब तक लाइक पार्टिसिपेंट्स ज्वाइन करेंगे लाइक में.
So, just a second.
आई थिंक राइट सर लेफ्ट आउट. रोहित सर प्लीज चेक.
हाँ सर, सर है नहीं, मैं फिर से बात चेक करता हूँ. सर लेफ्ट कर गए थे, ज्वाइन करिए सर ने फिर से, एक मिनट रुक जाइए.
Is my presentation visible?
यस सर.
Yes, sir. That's fine, sir.
Okay. So,
Sir,
I
please can you move 1 to 2 slides so we can check it's working properly? Yes, sir. It's
is
all
it
fine, sir.
वर्किंग सर, वर्किंग.
okay? But I
योर
can
वीडियो,
see myself.
योर वीडियोस देयर सर, वी कैन सी योरसेल्फ लाइक.
Yeah. Uh, okay.
Within 2 minutes, we will start, sir.
Sure.
हेलो रोहित सर, प्लीज सईदा मैम को पोस्ट बनाइए.
ओके सर.
A very warm welcome to all the participants to Christian Navyu a 3-month training come internship program. I, Ajay Sharma, PS2 founder and program coordinator of today's session. Before we begin, we have a quick update regards today's schedule. Due to an unforeseen schedules conflict, Dr. Uma Sharma sessions is began rescheduled for a later. To ensure optimal use of our time today, we have advanced the session of our distinguished experts, Dr. Jaiprakash Rai sir. We are immensely grateful to Dr. Rai sir for their flexibility and promptness in leading today's technical session. To official commence today's proceeding, I now invite Ms. Saida for the welcome remarks. Ms. Saida, please.
Thank you so much, sir. Am I audible?
Yes, you are
Yes,
audible.
ma'am.
So, good evening, everyone, and a very warm welcome to all the participants joining us today. I hope you are all doing well and are excited as I am for today's session. I am Saida Nahal Zahra, Technical Secretary to the founder of AWRF and the anchor for today's program. It is now my privilege to introduce our distinguished speaker whose contribution to agricultural sciences, plant pathology, and sustainable agriculture has left a significant impact on both academia and the farming communities. We are honored to have with us today Dr. Jaiprakash Rai sir, Associate Professor in the Department of Mycology and Plant Pathology at the Institute of Agricultural Sciences, BHU, and an accomplished expert in plant protection and agricultural microbiology. Dr. Rai has devoted more than 2 decades to teaching, research, extension, and capacity building in agriculture. His areas of specialization include mycology, plant pathology, plant protection, agricultural microbiology, plant biotechnology, and the dissemination of improved agricultural technologies. Throughout his distinguished career, he has mentored numerous MSc and PhD scholars and has taught a wide range of subjects, including plant pathology, agricultural microbiology, crop disease management, and molecular approaches to plant pathology. Dr. Rai's research contribution spans plant disease management, microbial interactions, biocontrol agents, sustainable agriculture, rhizosphere microbiology, as well as crop protection. His academic journey is reflected in an impressive body of scholarly work, including more than 90 research and technical publications, several book chapters, and over 16 book and manuals covering diverse aspects of agriculture, plant protection, and rural development. His work has been published in reputed national and international journals alike. Among his many recognitions, he has been honored with the prestigious Rajiv Gandhi Rashtriya Gyan Vigyan Maulik Pustak Lekhan Puraskar, conferred by the Government of India along with his several other awards, acknowledging his outstanding contributions to agriculture sciences and education. Beyond his academic achievements, Dr. Rai has actively worked with farmers, extension agencies, educational institutions, and scientific organizations to promote sustainable agricultural practices and strengthen the connection between scientific innovation and field level application. To be very honest, if I were to list all of Dr. Rai's achievements, publications, awards, and contributions, we would probably need a separate session for that altogether. His remarkable work continues to inspire students, researchers, farmers, everyone across the country. We are truly honored to have him with us today and look forward to benefiting from his vast knowledge and experience. Now, without any further ado, I warmly invite Dr. J. Prakash Rai sir to deliver his lecture. Sir, if you would, the virtual platform is all yours. Thank you.
Thank you, Ms. Saida. Uh, Respected organizers of this event, to Sharma ji, Rohit ji, and Dr. Srivastava, and everyone associated with this organization of this event and their participants. Today's topic of discussion will be mycotoxicological contamination, particularly with its implications of aflatoxins within the agri-food supply chain and secondary metabolic impact on food production systems. So it's a very important topic, and I think the audiences that I was apprised of will get much information from this topic, and it seems to be relevant to all of them. Now, thus the talk, it structure that we'll take an overview of aflatoxins. So those who are in a hurry, who have little time, they can leave after completing some slides of overview, because I have summarized all our complete talk within these slides. And then we'll go into detailed history of the aflatoxins, their implications, their effects on human civilization, animal health, and human health, prevalence and distribution of aflatoxins over the globe, over the different geographical regions, sources of aflatoxins from where they get contaminated, and impact on food production, their prevention and control, and lastly, future challenges and research needs for aflatoxins. Coming to the overview. Now, aflatoxins, as we all know, they are a group of secondary metabolites produced by a number of fungi, and primarily Aspergillus flavus and Aspergillus parasiticus, because these, if we take some letters from this name of the fungus itself, producing fungus itself, Aspergillus flavus, it constitutes the term afla, Aspergillus flavus, A flavus. And toxins, we have added it to its effects of the metabolites on the human and animal health. Now, these fungi, they typically grow on food crops and agricultural commodities, given the conditions favor them. In these conditions of temperature and humidity, they may vary from scenario to scenario. Storage and post-harvest conditions are most likely to present favorable conditions for production of aflatoxins and invasion of these agricultural commodities by these fungi, aflatoxicogenic fungi. And these fungi are aflatoxins are considered potent carcinogens, means cancer-producing compounds, and they pose significant risks to the health of humans and farm animals. Aflatoxins are known to contaminate various food products after invasion of these apoptotic fungi. Coming to the types of aflatoxins, we have aflatoxin B1. It's the most toxic and common type of aflatoxin that is known to be a potent carcinogen, has been grouped as group 1 carcinogen, means it's carcinogenic to humans also. I would request the audience to please be attentive, because at the end of the talk, I will be putting some questions to you, and we'll be discussing the things. We'll be summarizing the things and recapitulating the talk, so that we may better have an idea of the key takeaways of this talk. So please be attentive and note down the important things that you think is important. Aflatoxin B2 is less toxic than B1, but still it's hazardous. And then come aflatoxin G1 and G2. They are characterized by a green fluorescence when exposed to UV light. So that's why green fluorescence has given them the name of G1 and G2. Then comes aflatoxin M1, a metabolite of aflatoxin B1, which is found in milk. Upon consumption of aflatoxin contaminated feed by dairy animals, and it's found in milk and dairy products from the animals that consume contaminated feed. Coming to toxicity and health impacts, carcinogenicity is one of the most important and most pronounced effects of aflatoxins that has been encountered so far. Aflatoxin B1 is classified as group 1 carcinogen by the International Agency for Research on Cancer, IRC. That means group 1 carcinogens means it's carcinogenic to humans. It can cause cancer to humans. And its prolonged exposure is linked to liver cancer, particularly in regions with high dietary exposure, where its aflatoxin or Aspergillus flavus contaminated feeds are consumed to a greater extent. Next is acute toxicity. In higher doses, aflatoxins, they can cause damage to the liver, its failure, and sometimes death also. Symptoms of acute poisoning by aflatoxins, it may include nausea, vomiting, abdominal pain, and jaundice, and hepatomegaly, that is enlargement or swelling of liver upon consumption of these aflatoxins. Again, toxicity and health impacts we see. Chronic toxicity leads to low levels of aflatoxins. They can lead to immunosuppression, growth retardation, liver cirrhosis, and other health complications. They're also known to cause damage to the kidneys and other organs, which are our In fact, kidney and liver, these two are our vital organs for life, and we both are affected by the aflatoxins. Coming to effects on children, they can cause stunting in children, retardation of growth, and they can impair cognitive development in children, leading to ADHD and ADHD-like symptoms. And sometimes it may, and together, all these, they make vulnerable children vulnerable to their social regime. Coming to contamination of aflatoxin and to its detection, they typically contaminate crops during their growth phases, and they remain on the produce even after harvesting or storage, especially under conditions of high humidity and inadequate drying of the agri produce. Hot and humid environments are particularly favorable for this growth of fungi. And once aflatoxin producing fungi infest the crops or its produce, it's very difficult to eliminate this contamination, because they are highly saprophytic and they can survive on even on the dead decaying organic matter that is rendered by plant residues or plant produce that we are going to store, or that is the ultimate produce of our crop cultivation practices. Detection of aflatoxin it may involve chemical analysis of the compound, high performance liquid chromatography, HPLC, or ELISA, and other analytical methods are there which can detect varying amounts of aflatoxin in food products. And visual inspection, even as we can see in the photographs to the left of the slide, visual inspection can give us the indication of the level of invasion of the food product and the level of aflatoxin contamination of the related food product. In many cases, these growth of fungi, it is visible on the food product, and it is quite relative in amounts to the amount of aflatoxin. Coming to regulatory standards, there are several countries, they have established regulations for allowing permissible levels of aflatoxin in food and feed to protect public health. There are two examples. The European Union and United States, they have strict limits on aflatoxin levels in foodstuffs, particularly in peanuts, corn, and other susceptible crops. The Codex Alimentarius, the committee, has set international guidelines for aflatoxin limits in foods, but standards they vary from country to country, from developed to developing countries and to underdeveloped countries. These parameters they have variations. Lastly, to prevention and control of aflatoxins, to reduce its contamination, several strategies are employed, as we all know: good agricultural practices, crop rotation, cultivation of resistant varieties to mold growth, and proper irrigation, maintenance of temperature and humidity to the optimum level, so that the food product or the agricultural produce may not be contaminated by these saprophytic fungi, which can produce aflatoxins. Proper harvesting and storage practices that ensure the crops or produce is dried adequately to the desired moisture levels, and it's stored in cool, dry conditions to prevent the growth of mold in and out of storage. Post-harvest treatment, there are certain treatments, for example, fungicides or physical removal of contaminated crops and sorting to reduce the levels of aflatoxin. Even physical sorting of these contaminated produce from the healthy ones, it may give important control over the infestation. Coming to the tail now, those who are in a hurry, they have got the gist of the entire talk, and now we will detail the topic from point wise. The history, it dates back to early 1960s, but the impact and its recognition in food safety and public health, it got importance since then. Now, coming to we'll look into the timeline of the key events and development in the history of aflatoxins. before 1960s, there were early signs of toxicity in agriculture and food products. Before its proper identification, there were reports of mysterious animal deaths, and certain crop diseases were related to them, and it seemed to be caused by the contamination by fungi. Now, the specific connection to these fungal agents and their byproducts, metabolic byproducts, and their impact on the animal health or human health, it was not related or not established at that time. Agriculture communities were aware of the issues that were related to fungal growth on agri produce, but the exact cause of contamination, it was not very much clear because we didn't have that much tools and technology for its detection and identification. Now, 1960s are a milestone in the history of aflatoxins because they were discovered in only after that. In 1960, there was widespread outbreak of this Turkey X disease. X means when we do not have any idea about anything, we call it X or XYZ. So Turkey X disease means Turkey disease of Turkey that was unidentified, that was the cause of which, the etiology of which cannot be established because there was no parasites, no pathogen involved in disease, but still it was a disease. So pathological diseases, they are called, sometimes they are called X disease because they do not have any etiology established. So it was called Turkey X disease of Turkey. Well, disease of Turkey that about which we don't know much, but it's a disease. The disease got a widespread occurrence in United Kingdom, and tens of thousands of turkey and poults in the country, they died mysteriously after consuming contaminated peanut meal that was imported from United States. Okay, so this caused a significant public health scare. The animal showed signs of damage, and the cause was traced to aflatoxins produced by Aspergillus molds. Because these turkey were consumed by humans, it was the society got scared because they might also get these levels of toxins in their bodies, and they might get diseased, or they might get some serious health complications. In 1962, the aflatoxin was identified by Dr. S.A. Goldblatt and his co-workers, and they identified the molds, particularly Aspergillus flavus and Aspergillus parasiticus, related to the production of aflatoxin in these food and feed to the animals, and they named it aflatoxin, Aspergillus flavus toxin. In short, it's called aflatoxin. In 1970s, we tried to understand the toxicology of aflatoxins, carcinogenicity and health risk. They came to the light, they came to the notice of the scientific world. And during 1970s, the scientists, they discovered that aflatoxins were not only toxic to animals, but also carcinogenic to humans. The B1, aflatoxin B1, it was shown to be a potent liver carcinogen, and subsequent studies in animals, they established its ability to induce liver tumors. And aflatoxin M1, that was from milk, metabolite of aflatoxin B1 used by dairy animals and found in milk. It raised concerns about contamination of the food chain because the feed was contaminated with aflatoxin B1. It was consumed by the dairy animal, and the milk that we got from this such animal fed with aflatoxin B1 contaminated feed, it contained aflatoxin M1, and this aflatoxin M1, it came through entire food chain to the human diet. In 1975, the international organizations began to take action, and Codex Alimentarius Commission, that's the apex body responsible for setting international food standards. It included aflatoxin in its guidelines for food safety, and this was a significant step in recognizing the global concern of aflatoxin contamination. In 1980s, it was the recognition of global concern. We had much information about aflatoxins and their impact on human and animal health. the countries began to establish regulatory limits and permissible limits for aflatoxin in food and feed. In the United States, the Food and Drug Administration, it set maximum allowable limits of aflatoxin in various food products, particularly peanuts and corn, which were the prime produce of United States, and they were known to be susceptible to contamination. Still now, peanut and corn are the most vulnerable agri produce that are that can be infected by Aspergillus flavus and Aspergillus parasiticus, and they are potent sources of aflatoxins in animal feed and human diet. In 1981, aflatoxin research expansion was done, and research into detection, prevention, and control of aflatoxin contamination. It grew quite rapidly over the globe. Improved detection methods such as high performance liquid chromatography (HPLC) and they were developed to identify and measure aflatoxin levels in food products. And studies also explored ways to reduce mold contamination in crops, including better storage practices and use of fungicides to reduce mold contamination and resultant aflatoxin levels in the agri produce. In 1990s was the decade of aflatoxins and global health. In 1993, aflatoxin B1 and cancer, they were related, and it was established that the cancer is caused by aflatoxin B1 in animals and also in human. So in human, when it was discovered that it can cause cancer in humans also, it was kept in the category of group 1 carcinogen. So it confirmed its cancer causing potential in humans, and this corroborated aflatoxin status as one of the most dangerous naturally occurring toxins. In 1990s, emerging risk in developing countries, since developing countries were striving for food to feed the entire population, it was very difficult to have the ample amount of agri produce. Aflatoxin contamination became a primary pressing issue in developing countries where hot and humid climates and inadequate storage conditions and limited access to food safety regulations made crops more vulnerable to fungal contamination and aflatoxin production. Cases of aflatoxin-related diseases, including liver cancer, were reported in countries like Africa and Asia. In the countries in the continents of Africa and Asia, raising concerns about the global scale of the issue. From 2004 to 2015, we have international collaboration of aflatoxin. The World Health Organization, it recognized, and United Nations, they began collaborative efforts to reduce aflatoxin contamination globally. And there were attempts which were focused on education, training, and the introduction of better agricultural practices in the affected regions to reduce the incidences of aflatoxin contamination and consumption. Now, in 2010s, there were significant advances in detection technology, such as rapid testing methods for aflatoxins. It made it easier to monitor food producers for contamination. And further, research continued into biological control methods, including the use of competitive non-toxic fungi to prevent aflatoxin-producing fungi, Aspergillus flavus and parasiticus, from contaminating crops. So, kind of biological control to release aflatoxin-producing fungi in food products. And in 2015, global action on aflatoxins took place. In the Global Food Safety Initiative, GFSI, it recognized aflatoxin as one of the top priorities for food safety over the world. International standards for the safe levels of aflatoxin in food countries to evolve. From 2018 to recently 2021, in 2018, European Food Safety Authority statement on the possible effects of on human health of an increase in the maximum permitted levels of aflatoxins in peanuts and peanut-based products. In 2019, 25 confirmed aflatoxin producers of Aspergillus section flavi and section nidulantis and section ocraceorasi were reported. In 2020, Aspergillus texensis, Aspergillus agricola, and Aspergillus toxicus were found to be the new aflatoxin producers from Aspergillus section flavi. In 2021, promising novel and innovative approaches and technologies for aflatoxin mitigation were developed. Coming to prevalence and distribution of aflatoxin, this was all about the history of aflatoxins from pre-1960 to 2020s. Now, prevalence and distribution of aflatoxin will look into the map. In the areas which are red in color, they have high incidences of aflatoxins. And in yellow, there is less than 65% of aflatoxin contamination. And in areas that are green, it is less than 35% of agri-produce contaminated by aflatoxins. So India is one of them in green conditions. Still, there are countries we can directly relate to the economy of the country or its developing status to the level of contamination of aflatoxin, because in many of the countries which are struggling for feeding their own population, they have more incidences of aflatoxin contamination in their countries. Now, coming to the sources of aflatoxin in food and feed. First one is agricultural crops and commodities, particularly peanuts and corn, cottonseed, tree nuts, rice, and spices. Among these, peanut and corn, they are most important commodities in which aflatoxin producing fungi, they infest these two commodities, and production of aflatoxin in these two products is most pronounced. Second is animal feed and byproducts, including livestock feed and dairy products, in which we have aflatoxin M1 from milk. Third is contaminated soil and crops in the field. Crops like peanut and corn, which grow close to the ground, they are particularly vulnerable, and they have more incidences of fungal infection. And fourth is improper harvesting and storage practices. They lead to development of these growth of these aflatoxin producing fungi and increased levels of aflatoxin contaminations. High moisture content, inadequate storage facility, and physical damage, they lead to enhanced growth of these aflatoxin producing fungi and increased levels of aflatoxin contamination in the produce. Fifth is contaminated water and irrigation systems, because they can lead to introduction of the fungal species, aflatoxigenic fungal species to the field and crop, and they can lead to the storage and even in ultimate produce that is going to be sold in the market. Now, wild and imported foods, they are also sources of aflatoxin. Imported foods and wild harvested foods, because we do not know about their conditions, growing conditions. We are not sure about their growing conditions, and they may contain aflatoxin producing fungi, and in that ratio, they may have contamination of aflatoxins also. Now, seventh is aflatoxins in fungal infections. Certain types of fungal infections in foods of crops, they caused by mold, aspergillus, can lead to the production of aflatoxins. They are primarily sourced from the growth of aspergillus molds on a wide range of agricultural commodities, especially those prone to moisture and heat stress. Peanuts, corn, cottonseed, and tree nuts are some of the most commonly affected crops, and improper post-harvest handling and storage practices, they increase the risk of contamination of aflatoxins. Coming to impact of aflatoxins on food production. Now, they are naturally occurring mycotoxins produced by certain species of fungi, primarily Aspergillus flavus and Aspergillus parasiticus. These toxins are commonly found in agricultural products, especially those that are improperly stored or exposed to humid and warm conditions. In food production, aflatoxins are a significant concern due to their toxicity and carcinogenic properties, which can affect human health and food safety. Aflatoxins are particularly prevalent in cereals, nuts, dairy, and other agricultural products, and their presence in food can result to economic losses, regulatory challenges, and public health risks. Occurrence of aflatoxins in grains is the most significant incidence of mycotoxins that can contaminate in contaminated the food crops. Grains are particularly vulnerable to aflatoxin contamination because these aflatoxin producing fungi, they prefer to infect grains primarily produced by fungi from the Aspergillus genus, Flavus and Parasiticus species to spatial reference. And significant public health risk as well as serious economic consequences have been encountered by aflatoxin contamination. The grains that are affected by aflatoxins, there is a number of grains and agriculture produce that are infested by aflatoxin, particularly those commodities that are the crops from which they are grown in warm, humid climates where the fungi they sustain. The following grains are particularly susceptible to contamination, including maize, peanut, rice, wheat, barley, sorghum, and millet. Apart from these, tree nuts and several other seeds are also vulnerable to infestation by aflatoxin-producing fungi, and they contain serious levels of aflatoxins. Now, the process of contamination is that the agri produce is invaded by the aflatoxin-producing fungal species. The fungi grow on these agri produce and produce aflatoxins. Conditions favoring aflatoxin production include high humidity, high temperatures, physical damage to the agricultural commodity, and improper storage conditions. Coming to aflatoxins in food chain, human consumption, contaminated grains or contaminated agri commodities, for example, corn and peanuts, they are used in various food products, including flours, snacks, oils, beverages like corn-based drinks, and syrup and animal feed. Aflatoxin exposure in humans, it can lead to serious health problems such as liver cancer, immune suppression, and growth impairment. When aflatoxins are found in animal feed, they can contaminate animal feed. They may feeding up such contaminated feed to animals may lead to suffering of animal from toxicity. In addition, aflatoxin can enter the human food chain via animal products such as milk, meat, and eggs. Aflatoxin M1 can be contained in all these three animal products. If animals are exposed to aflatoxin contaminated feed, it can reach to the humans also through food chain. Coming to health risk associated with aflatoxin in grains, carcinogenic effects, we have already stated about these, that aflatoxin B1 is potent carcinogenic, human carcinogen, and it's grade 1 carcinogen, group 1 carcinogen. It has been recognized by International Agency on this, for Research on Cancer, IARC. Acute toxicity levels, including various kinds of symptoms, immune suppression, and growth impairment in children, and retardation, leading to stunting of the children. Monitoring and control of aflatoxin in grains can be done by regulatory limits, detection methods, and prevention and mitigation approaches to reduction in the levels of aflatoxin in food products. A very important thing is that aflatoxin, we have their contamination in nuts, and consumption of these nuts by humans and animals. It can lead to aflatoxin contamination and serious health hazards. Nuts, particularly those which are grown in warm and humid climates, they are highly susceptible in contamination with aflatoxin. Tree nuts, even forest nuts, they have high incidences of aflatoxin production, aflatoxin contamination when infested by these fungi, aflatoxin producing fungi. This kind of contamination, it poses significant health risk for humans and animals and can lead to economic losses due to crop damage, loss of product quality, and trade restrictions. And let's see what kind of nuts are affected by aflatoxins. Peanuts, we have already stated much about these peanut infestation by aflatoxin producing fungi, aflatoxin Aspergillus flavus and Aspergillus parasiticus. When peanuts are exposed to high humidity and high temperatures, they get readily infested by these two fungi, aflatoxin producing fungi. And when harvested under conditions of high humidity and high moisture, these peanut is bound to be infested by Aspergillus flavus and Aspergillus parasiticus, and leading to enhanced levels of aflatoxins in peanuts. Among tree nuts, several other types of nuts like almonds, pistachios, walnuts, and Brazil nuts, they are also susceptible to contamination by Aspergillus flavus and parasiticus. But peanuts remain the still most commonly affected nuts. These nuts can become contaminated both in field and during post-harvest storage and have varying levels of aflatoxins in their content therein. Coming to contamination process, pre-harvest contamination is one of the most important aspects of aflatoxin contamination. Fungal growth in the field can lead to its retention on the final produce, and when stored in conditions of high humidity and high temperature, these fungi can grow. They can have enhanced levels of aflatoxin in the final produce. Stress conditions of stress to the seed or to the agri commodity, it can lead to altered defense reactions of these seeds to the onslaughts of fungi, particularly those which have capabilities to produce aflatoxins, and they can surrender to the attacks of fungi, and these fungi can finally invade the seeds and they produce aflatoxins in amounts contemporary to their growth. Now, post-harvest contamination, it takes place in after harvesting, and fungi, when developed in storage conditions, particularly with contaminated stores and storage under high humidity and high temperature, and due to faulty handling and transportation practices, they may get infected by these fungi and may be contaminated with the aflatoxins. Coming to health risks that are associated with aflatoxins in nuts, carcinogenicity is one of the important aspects related with aflatoxin B1. Acute toxicity, immune suppression, growth impairment in children. It's being repeated, I think. Regulatory limits and standards for aflatoxins in nuts. European Union has set strict maximum limits for aflatoxins in peanuts and other nuts, with limits typically set around 4 parts per billion for aflatoxin B1 and 10 ppb for total aflatoxins. And the United States, the FDA, had established limits for aflatoxins in nuts, particularly in peanuts and tree nuts, where the allowable limit for aflatoxin contamination is set as 20 parts per billion for aflatoxin B1. So kind of relaxed in comparison with the European Union limits, and total aflatoxin in food products intended for human consumption. Okay. Coming to prevention and mitigation of aflatoxin contamination in nuts, pre-harvest management can be done by planting resistant cultivars, optimized irrigation practices so as not to increase humidity in field, relative humidity in the field, and management of crop canopy also, so that the microclimate may not favor the growth of these aflatoxin producing fungi, leading to further invasion of the agri produce and contamination and production of aflatoxin by them on the final produce. And insect control also, because insects, they cause damage to the agricultural commodity, the final commodity, the grain, seed, or whatever commodity we have. Now, insects can cause damage to them, and that can create excellent venues for fungal infection and infestation by these aflatoxin producing fungal species, Aspergillus flavus and parasiticus in particular, that can readily overcome the defense system of the agri commodity and lead to enhanced levels of aflatoxin contamination. In post-harvest management, we have proper drying, reduction of the moisture levels to the below 10 or below 8. It helps reduce the contamination, reduce the chances of contamination of the agri produced by fungi. Storage under optimum conditions, of particularly temperature and humidity. These two factors are quite important for invasion of agri produced by aflatoxin producing fungi. And sorting and cleaning of the produce, so as the healthy produce free of these aflatoxin producing fungi, it gets into storage. And coming to post-harvest treatment, when we have to ensure that if there is an aflatoxin producing fungus in the lot, it may get eliminated. There are physical treatments such as hot air and hot water treatments. Chemical treatments are there with fungicides, particularly those agri-produced, which is not intended for consumption to human and animal. For example, cotton seed, cotton and other commodities. And biological control, we have seen some examples of biological control of aflatoxin producing fungi by challenging them with other fungal agents or bacterial agents, which can reduce their growth and expansion in the lot. Coming to aflatoxins in fruits and vegetables, although they are very less in amounts, and aflatoxin producing fungi, they rarely prefer these fruits and vegetables because of the outer covering or the skin of the fruits and the vegetables. These have compounds that are not very much suitable for fungal growth or bacterial growth. But when these are ruptured or the skin is damaged, these fungi and the bacteria, they get entry into the fruits and vegetables. And fungi, particularly with the capabilities to produce aflatoxin, when they invade fruits and vegetables, aflatoxins are also produced in fruits and vegetables, such fruits and invaded fruits and vegetables. They become vulnerable, and when these conditions of humidity and temperature, they are favorable for fungal growth, aflatoxins may be produced in fruits and vegetables also. When fruits and vegetables are affected by aflatoxins in fruits, it may be grapes, figs, apple and pears, citrus fruits, and among other fruits, papaya and banana may also get infected by Aspergillus flavus and parasiticus, and may get some amounts of aflatoxins in them. Among vegetables, chilies, tomatoes, and cucumbers and eggplant are also important in terms of their getting infested by these fungi, aflatoxin producing fungi, and may contain varying amounts of aflatoxins in them. The process of aflatoxin contamination in fruits and vegetables, it starts from fungal growth in the field itself, and pre-harvest conditions of enhanced temperature and humidity and enhanced crop canopy, it may lead injury to the crops, and invasion facilitates invasion of the fruits and vegetables by fungi, aflatoxin producing fungi. In post-harvest contamination, moisture consideration and storage and transportation conditions are quite important. And how we can prevent the incidence of aflatoxins in fruits and vegetables by pre-harvest management of crop, planting resistant varieties, and management of environmental conditions, particularly crop canopy and temperature and humidity, keeping them optimum to reduce the fungal growth, and management of insects so that they cannot damage the fruits and vegetables in the field, and open entry points for these aflatoxin producing fungi. In post-harvest management, we can do proper drying of the commodity so that it may not contain favorable amounts of humidity or moisture, and alter temperature levels for enhanced fungal infection and production of these aflatoxins. And adequate storage conditions, sorting and removal of infested fruits and vegetables from the healthy lot. And biocontrol and chemical methods are also important in reduction of these aflatoxin producing fungi, leading to reduction in the amounts of aflatoxin that finally produced. Coming to aflatoxicity, that's one of the important points that we have been later priced off, and they are significant concern in dairy production, as they can be transferred from contaminated animal feed into the milk and dairy products, posing a serious risk to human health, because milk is still considered the most innocuous kind of food and complete food. And milk, since it's fed to the children and infants, its contamination by aflatoxin to small levels, it can lead to greater health implications in children and infants because their body weight is very less. The toxins involved, mainly aflatoxin B1, the most toxic form of aflatoxins. It can contaminate cattle feed. It includes aflatoxin contaminated grains, peanuts and corn and forages. Once the contaminated feed is consumed by the dairy animal, the toxins can be metabolized into aflatoxin M1. Now see, aflatoxin B1 is consumed by the animal and it gets converted into aflatoxin M1 that can secrete in the milk, that can get entry into the milk, and it can later make its way to the into the dairy products produced from milk, paneer, and number of items that are produced that are prepared from milk, and all the products may contain varying levels of aflatoxin M1 depending on the quantity of aflatoxin M1 in the milk from which they have been produced. Now, dairy cattle often consume corn, peanut, cottonseed, forages, and other grains that are quite susceptible and vulnerable to aflatoxin contamination. The fungi that produce aflatoxins, they survive in warm and humid environments, and particularly in regions where these conditions prevail. Poor storage practices such as inadequate drying or improper humidity management, it can further increase the risk of aflatoxin contamination in animal feed. And metabolism of aflatoxin in dairy cattle, like we stated that aflatoxin B1 consumed by the animal, it gets converted to aflatoxin M1 that can come into the milk. Aflatoxin M1 is a hydroxylated form of aflatoxin B1. This aflatoxin M1 is much less toxic than aflatoxin B1, but still it's carcinogenic and toxic. And it becomes most important when it comes to the feeding of milk, such milk, contaminated milk by infants and children. The aflatoxin M1 is then excreted in the milk of dairy cattle, potentially contaminated both raw milk and processed dairy products. It can be found, aflatoxin M1 can be found in a variety of dairy products, including milk, cheese, butter, yogurt, paneer. This contamination poses a serious food safety risk because it is persistent in milk and dairy products, and it does not degrade easily during normal processing. If you think that you can reduce its amount by simple processing methods, you cannot reduce its quantity. Dairy products, they are often consumed in large quantities, increasing the human exposure to aflatoxins if contamination is present. So large quantities, consumption of dairy products in large quantities, it leads to consumption of aflatoxin M1 in quantities that are critical for human health and to produce symptoms of toxicity. The risk to human health is particularly high for infants. We stated earlier, with young children and immunocompromised individuals, such as aflatoxin M1 can be carcinogenic, mutagenic, and immunosuppressive. The amount of aflatoxin M1 that appears in milk, it depends on a number of factors, which may include that the level of aflatoxin B1 in the feed. The more aflatoxin B1 in the feed, the more aflatoxin M1 in the milk of the cattle. The amount of feed consumed by the animals. The more amount consumed by the feed of the consumed in form of the feed by the animal, the more level of aflatoxin M1 in its milk. The conversion efficiency of aflatoxin B1 to aflatoxin M1 in the liver of the dairy cow, it depends from breed to breed, and many breeds have been shown to have higher efficiency of conversion of aflatoxin B1 into aflatoxin M1 in their liver, and their milk can be quite dangerous for human health. The type of dairy cow, individual animal metabolism also depends on the levels of aflatoxin M1 in the milk. In general, the concentration of aflatoxin M1 in milk is directly proportional to the amount of aflatoxin B1 in the feed that was consumed by the animal. Regulatory bodies worldwide, such as FDA, Codex Alimentarius, and European Union, they have set limits for aflatoxin M1 in milk to protect public health, and particularly in children and infants. Coming to regulatory limits for aflatoxin M1 in the milk. Several international organizations and countries, they have set maximum allowable limits, maximum permissible limits for aflatoxin M1 in milk to minimize the risk of human exposure. Codex Alimentarius has set the maximum limit for aflatoxin M1 in milk to be 0.05 parts per billion. You see, what a strict limit. US Food and Drug Administration has set the limit to 0.5 ppb, relatively flexible and higher than Codex Alimentarius. And European Union, it has followed the recommendations of Codex Alimentarius and had set the limits for aflatoxin M1 in milk to 0.05 parts per billion. And these regulatory limits, they ensure that aflatoxin contamination in dairy products is kept to a minimum and that consumers are not exposed to harmful levels of toxins. Coming to impact of aflatoxin in dairy on human health, the primary health concern regarding aflatoxin in dairy products, it comes from the carcinogenic and toxic properties of aflatoxins, particularly aflatoxin M1. The major risks, they include carcinogenicity, aflatoxins that are classified, particularly aflatoxin B1, that has been classified as group 1 carcinogen by the International Agency for Research on Cancer, IRC. Long-term exposure to aflatoxin, even in small amounts, increase the risk of liver cancer. Mutagenicity, that's one of the important and most pronounced effects of aflatoxin consumption. They are capable of causing mutations in DNA, which can lead to genetic damage and it cannot be reversible. Immunotoxicity. Aflatoxins can suppress the immune system, increasing susceptibility to infections, and a number of infections can occur in such human with immuno vulnerability. And toxicity to organs. High dosage of aflatoxin can cause to acute liver damage as well as damage to kidney and lung due to its toxicity. Now, this picture shows that how Aspergillus species can get into our food chain. Animal feed infested by Aspergillus species, it can get infested by aflatoxin B1. It can get consumed by the dairy animal, and aflatoxin M1, it can come in the milk of the dairy animal, and it can be ingested by the young. Even these AFB residues, they can get into our body by direct inhalation or dermal contact. In handling of animal feed infested with aflatoxin B1, we can get its infestation in our lung, in our body by direct inhalation or dermal contact. When it comes to contaminated cereals, we can get into our body by direct inhalation or dermal contact during handling of such contaminated cereal, and its residues in various products produced from these contaminated cereal, maize or peanut or cottonseed, we can get ingestion of aflatoxin B1 into our body that is more toxic than aflatoxin M1. Acute aflatoxicosis, the symptoms of acute aflatoxicosis include nausea, icterus, vomiting, bleeding, abdominal pain, convulsions, and coma, and sometimes death. And chronic aflatoxicosis, hepatocellular cancer, hepatomegaly in particular, immune suppression, mental retardation, liver cirrhosis, reduced reproductive performance. So these are the effects of aflatoxins on human health and animal health when it comes in our food chain, either through animal or through direct agriculture commodity. Coming to methods of reducing aflatoxin contamination in dairy production, there are several strategies that are employed to reduce aflatoxin contamination in dairy products, focusing on both the prevention of contamination in feed and management of toxins in milk. Prevention at the feed level includes monitoring and testing of the animal feed, improved feed storage practices with optimum moisture and temperature levels, humidity and temperature levels, and use of aflatoxin binding agents that can exclude these aflatoxins from the feed. And managing aflatoxin M1 in milk includes milk testing, feed management, and control of aflatoxin M1 through processing. Environmental factors, there are certain environmental factors that can increase the risk of aflatoxin contamination. They particularly climatic, agriculture, and storage factors. Understanding these environmental factors is crucial for preventing aflatoxin contamination, safeguarding public health and food safety. I said that planting of resistant varieties to fungal infections, insect control so that they cannot cause damage to the agri produce and lead to infestation by fungi, secondary infection by fungi, and management of canopy of crops so that not to make the microclimate favorable for growth of the fungi that are producing aflatoxins. Now, these are fungi, aspergillus or other genera agriculture produce. Biological factors include pre-harvest, post-harvest, and storage among agricultural factors. And among environmental factors, humidity, temperature, and climate changes. These two, they can govern the level of contamination of aflatoxin in the agricultural commodity. And further, food crops and animal feed processing may lead to the quantity of aflatoxin in human food and aflatoxin intoxications. And these can get from poultry, livestock, and from animal products such as aflatoxin M1, contamination of aflatoxin M1 in human food, and aflatoxin intoxications. Now, coming to the factors that are very much responsible for aflatoxin production in agricultural commodities, temperature is one of the most important factors behind growth of fungi, and it can regulate a number of infestation of fungi producing aflatoxins. Warm temperatures are one of the primary environmental factors that favor the growth of aflatoxin producing fungi. Aspergillus flavus, it survives in temperatures between 25 to 30 degrees Celsius. So any feed or food stored between these temperatures, stored above 25 degrees Celsius, it has risk of being contaminated by aflatoxin producing fungi, Aspergillus flavus. Higher temperatures, especially during the growing season or post-harvest storage, it encourages the fungi, these Aspergillus flavus, to produce aflatoxins by its metabolic pathways. In tropical and subtropical regions where temperatures are consistently high, the risk of aflatoxin contamination in crops like maize, peanut, and cotton is quite high. Humidity and rainfall. Humidity is the second most important factor determining the growth of aflatoxin producing fungi. High humidity and rainfall, they are significant risk factors for aflatoxin contamination. Humid conditions during growing period, more irrigation, frequent irrigation, and retention of soil moisture for longer periods, they can produce conditions that are quite favorable for growth of these aflatoxin producing fungi. Rainfall during maturation or harvest period can directly expose the final agri produce or grains or these nuts to fungal invasion. It can be especially problematic, and it creates conducive environment for fungal growth and can lead to damaged crops, which are more likely to be infected by species of Aspergillus. After harvest, high humidity levels during storage create ideal conditions for fungal spores to proliferate and produce aflatoxin in stored grains, nuts, and other feed crops. Drought stress during growing season significantly increases the likelihood of aflatoxin contamination. Crops such as maize, peanuts, cotton, they are particularly susceptible to aflatoxins during periods of water stress. Drought reduces the plant's natural defense mechanisms and makes it easier for fungi like Aspergillus flavus to infect the plants and produce aflatoxins by their metabolic reactions. Stressed plants may suffer from cracks, injuries by insects, or damaged kernels, which can provide excellent entry points or excellent venues for entry for the fungal spores to infect and contaminate the crops. This secondary infection and by saprophytic fungi can lead to production of aflatoxins in quite considerable amounts. Soil conditions and plant health also determines the level of aflatoxin contamination in the final product. It can also play a role in determining the susceptibility of crops to aflatoxin producing fungi. Poor soil health or low nitrogen and phosphorus levels can lead to weak plants, which challenged or altered or compromised defense mechanism, increasing the likelihood of increased fungal infections. And plant health is crucial. Crops that are stressed by poor soil conditions, pest damage or diseases, they are more prone to fungal attack. Mechanical damage from insects or wind, they can also create wounds in plants, which provide excellent entry points of venues for aflatoxin producing fungi. Insect damage like weevils, corn earworms, and aphids, they can contribute significantly to the development of aflatoxin by causing physical damage to crops. They make entry points for aspergillus fungi to invade the plant tissues and produce aflatoxins, because these aspergillus they find it difficult to cross the first barrier, physical barrier of the seed, that is outer skin. Insects can also spread fungal spores from one plant to the another, amplifying the risk of contamination. So this lateral contamination of aspergillus species is brought about by these insects. Crops like maize and peanuts, which are often attacked by insects, they are particularly vulnerable to aflatoxin contamination due to this mechanism. Cropping patterns and crop rotation. Monoculture cropping systems can lead to increased risk of aflatoxin contamination. This is because continuous planting of susceptible crops in the same area creates concentration of fungal spores in the soil, which can infect subsequent crops, because primary inoculum is already there and its buildup has been done from years over years, and they find it easy because inoculum density is quite high. So level of infection may be quite high in the beginning itself, and that can lead to the much enhanced amounts of fungal invasion the final produce when the crop is gets mature. Improper crop rotation or lack of diversity in farming systems, it can also increase the risk, as the same crops are repeatedly exposed to aflatoxin producing fungi. Crop rotation with less susceptible plants can reduce the buildup of initial inoculum in the soil and help break the cycle of contamination of these contamination by these aflatoxin producing fungi. Poor post-harvest handling and storage conditions also determine the level of aflatoxin in the final produce. After harvest, improper drying, storage, and handling of crops can create conditions that can favor the growth of aflatoxin producing fungi. High moisture content in harvest crops, particularly grains, nuts, and oilseeds, they create ideal environment for aspergillus flavors to proliferate and grow and produce aflatoxins in amounts commensurate to their growth. Improperly dried crops, particularly in regions with high ambient humidity, are vulnerable to aflatoxin contamination because of high moisture content. It is essential to dry crops thoroughly to a moisture level of below 13 to 15% to prevent fungal growth. I would recommend drying of agriculture commodity to below 10 to 8% if it doesn't affect its viability. And it has been found quite effective in reducing the incidences of aflatoxin contamination in the feed the agricultural produce. Poor ventilation and overcrowded storage areas can lead to high humidity and warm conditions, which further increase the risk of aflatoxin production by these fungi. Adequate airflow, temperature control, and proper storage conditions are key in reducing the risk of aflatoxin contamination and aflatoxin producing in the agricultural produce. Climate change and extreme weather events have been also found to determine the levels of aflatoxin contamination in the feed. The impact of climate change is becoming increasingly evident in the spread of aflatoxin contamination. Higher global temperatures, more frequent droughts, and increased rainfall variability can all contribute to higher incidences of aflatoxin contamination. Extreme weather events such as flooding, unseasonal rains, or heat waves can cause damage to crops, weakening plants and increasing their susceptibility to fungal infections. Furthermore, climate change is expected to shift the geographical range of aflatoxin producing fungi to regions that were previously less affected and were known to free of these aflatoxin producing fungi. Wind and soil erosion, they can also contribute to the spread of aflatoxins. Wind-borne fungal spores of Aspergillus flavus and Parasiticus can be carried from infected crops to healthy plants, leading to new areas of contamination. Additionally, soil erosion can spread fungal spores from one field to another, increasing the overall contamination risk. Human and agricultural practices also have their effects on aflatoxin contamination. Inadequate pest management and poor agricultural practices, they can exacerbate the environmental conditions conducive to aflatoxin contamination. Lack of IPM systems can lead to high insect infestation, while improper handling to harvesting techniques can increase the likelihood of mechanical damage to crops, making them more susceptible to fungal infection. Lack of education on safe storage and harvest timings among farmers can lead to mismanagement of harvested crops, leading to high risk of aflatoxin contamination. And farmers may not have an idea of ideal storage conditions so as to reduce the risk of aflatoxin contamination fungi. Storage conditions and aflatoxins have it's very important point to be discussed. The storage conditions of crops and food products play a critical role in determining the risk of aflatoxin contamination. Aflatoxins are produced by Aspergillus flavus and parasiticus. These fungi, they can thrive in poorly managed storage environments with high humidity and temperatures. These mycotoxins are serious concerns in stored grains, nuts, oilseed, and other food commodities, as they pose significant risk to human and livestock health. Proper post-harvest handling and storage practices are important to prevent aflatoxin contamination. Understanding the key factors, temperature and humidity in particular, that influence fungal growth and aflatoxin production in stored products, it can help reduce the risk of contamination and ensure our food supplies to be safer for human and animal health. Moisture content in crops, especially grains and oilseeds and nuts, is one of the most important factors that promotes the growth of Aspergillus species in the crop and subsequent aflatoxin production in the storage. Ideal moisture range for fungal growth is above 13 to 15% in stored crops. Critical moisture level is 14 to 15%. It's high risk of posing high risk of fungal contamination, and prevention can be done by bringing the moisture content below 13 to 14%. And below 10% if viability is not compromised to prevent the fungal growth. Warm temperatures are conducive to growth of aflatoxin producing fungi, bringing it below 25 degrees Celsius. It has been found effective in reducing the incidences of aflatoxin producing fungi in the field, and subsequent environments can be managed for reducing the incidences of these aflatoxin producing fungi, Aspergillus, parasiticus, and flavus. Low temperatures can inhibit fungal growth, but must be managed to avoid condensation, because that can again increase the risk of these fungi by increasing moisture levels to create a favorable environment for fungal infestation. Optimal storage temperature is below 20 degrees Celsius. Lower temperatures, they can reduce fungal growth and aflatoxin production. High ambient humidity during storage increases likelihood of fungal growth and aflatoxin production. If the relative humidity is consistently above 70 to 80%, the risk of fungal contamination is considerably heightened. Humidity levels must be controlled to prevent moisture buildup within stored crops, as fungi need both high moisture and high humidity to grow. Ventilation and airflow, they do reduce high moisture content and humidity and temperature also, and thus they play a crucial role in controlling humidity and temperature levels and ensuring moisture does not accumulate in stored products, and therefore it's important to they are important in terms of reduction of aflatoxin pollution, dry and fungal contamination of the agri produce or stored products. Airflow and ventilation. We've seen that it's essential to maintain dry, cool, and low humidity conditions in storage facilities. Stagnant air can trap moisture in storage space and cause temperature fluctuations, and it can contribute to the growth of Aspergillus flavus and production of aflatoxins subsequently. Improved airflow and ventilated storage facilities are essential in managing temperature and moisture levels in storage area. The duration of storage also matters, and the longer the duration for which crops are stored, the greater is the risk of aflatoxin contamination, because keeping it stagnant for longer periods is not considered optimal. Long-term storage increases the opportunity for fungal spores to establish and grow, especially if there is temperature and moisture fluctuations. And frequent monitoring of the stored products is important to detect early signs of fungal growth and prevent development of aflatoxins. Insect infestation in storage can also lead to contamination of the agri produce by mycotoxin producing fungi. Insect damage can significantly increase the risk of aflatoxin contamination by providing entry points for fungal spores and creating favorable conditions for fungal growth. Effective pest management is necessary to minimize insect damage in the stored products. Storage method and material. The type of storage facility and materials that are used in for storage, it can influence the potential of aflatoxin contamination. Traditional storage methods that trap moisture, such as jute bags or mud silos or plastic bags, they are more likely to promote fungal growth compared to modern, well-ventilated and climate-controlled storage facilities. Airtight containers or hermetic storage are effective in controlling the external environment, preventing moisture ingress, and limiting the growth of fungi. Storage facilities with proper sealing, insulation, and temperature control, they help ensure safe storage, and they can prevent the contamination of the produced by mycotoxin producing fungi. Handling and movement of the produce during storage is also important because it can create pockets of high moisture that are conducive to fungal growth. Rough handling of grains or other crops, then it can lead to damage to the kernels or husks, and that can provide a pathway for the entry of the fungal spores to the produce, and that can lead to production of aflatoxins. Grain cleaning and sorting. Prior to storage, cleaning and sorting to remove damaged grains, insect-infested kernels, and moldy grains can significantly reduce the risk of aflatoxin contamination, because in storage, the primary inoculum can be reduced. Damaged or infected grains are more susceptible for fungal infection, and their presence in storage can lead to rapid spread of fungal spores along the entire batch, across the entire batch. And regular inspection of stored crops, it can also help identify early signs of contamination and allow for timely intervention to reduce the contamination. Prevention strategies for safe storage. Dry crops thoroughly to moisture levels below 13 to 14% before storage, and below 10% I would recommend if viability is not compromised of seeds. Store grains in cool, dry conditions with low humidity and adequate ventilation to control moisture and temperature. Use insect control measures to prevent damage by pests and ensure proper grain hygiene. Monitoring of storage conditions on a regular basis, and implementation of early detection systems for moisture and temperature fluctuations. Sensors and alarms can play an important role in this. And hermetic storage or airtight containers that can regulate moisture and temperature, they can reduce fungal growth risks. And using aflatoxin binding agents in feed or other vulnerable products as a precautionary measure against contamination. And coming to prevention and control measures in agriculture, crop management, use of resistant varieties, aflatoxin resistant or tolerant crops that can reduce the likelihood of fungal contamination. Research, it has led to the development of genetically modified crops like BT maize, which has shown improved resistance to aflatoxin producing fungi. Crop rotation and diversification, it can help break the life cycle of fungi that can produce aflatoxins in storage. Growing different crops at the same land every season reduces the chance of fungi being specific to certain crops like maize and peanuts from getting accumulated. Optimal planting and harvesting time. Planting crops at the right time and harvesting them before the onset of extreme heat and drought can reduce the stress on plants and limit fungal growth. Adequate moisture during growing season supports healthy plants that are less susceptible to fungal infection. Soil health and fertility. Maintaining healthy soil using organic fertilizers or composting reduces stress on crops, making them less susceptible to fungal diseases. Maintaining soil fertility with the appropriate use of nitrogen, phosphorus, and potassium fertilizers can also help. In field management practices, pest control and proper irrigation are much important. Integrated pest management strategies have been found to help reduce the pest load on the crops and subsequent damage to the kernels or grains, and infestation by mycotoxin producing fungi. Proper irrigation is also important to prevent the buildup of moisture that is favorable for infestation of aflatoxin producing fungi. Adequate irrigation and water management practices can prevent environmental stress on the crop, reducing the susceptibility to fungal infection. In post-harvest management, we have efficient harvesting practices, timely harvesting, and proper handling of harvested crops, because over-ripening of the produce leads to its vulnerability to fungal infection, fungal contamination, because of the degradation of the outer physical defense systems. Delayed harvest can lead to higher levels of aflatoxin contamination, especially in hot and humid conditions. Now, damaged crops are more likely to be infected by aflatoxin-producing fungi. Drying and storage are of particular importance in terms of reduction of aflatoxin producing fungi in the lot. Proper drying to reduce moisture content, fungal growth, and aflatoxin production is highly dependent on moisture. Crops should be dried or produced should be dried to a moisture level of below 12 to 13% for grains like maize and peanuts that can restrict the growth of aflatoxin producing fungi on their surface. Improved storage conditions, proper ventilation, temperature control, and humidity management are key to reducing fungal growth. Hermetically sealed containers and metal silos, we have earlier emphasized on that. Inert storage material like bentonite clay or activated carbon during storage can help bind aflatoxins in contaminated crops and reduce their potential for exposure to humans and animals. So these aflatoxin binders are gaining importance in the days to come in management of aflatoxin in agricultural commodities. Food processing and detoxification, sorting and cleaning is the first hand measure that we can take. Visual sorting of crops, especially when we find that nuts and grains, they are moldy, they have fungal growth. We can sort and we can discard them from the main lot so that the fungal infection or fungal spores, they cannot get into the storage. Mechanical cleaning like air stream cleaners or gravity separators, they can help remove the contaminated portions of the harvested crops and thus reduce the likelihood of aflatoxin transmission into the final products. Physical detoxification, physical methods like thermal treatments, roasting or boiling, it can reduce aflatoxin levels in the food products by bringing down the moisture content or moisture levels to the optimum levels. However, they are not always sufficient to completely eliminate aflatoxins. Chemical and biological detoxification. Chemical detoxification such as using ammoniation, it has been investigated to reduce aflatoxins levels in certain products like grains and peanuts. Biological detoxification techniques such as using microbial cultures, for example, certain lactic acid bacteria or enzymatic processes that can help degrade aflatoxin in food and feed, kind of biological control or organic control. Use of aflatoxin binders in animal feeds like bentonite clay, activated carbon, or aluminosilicates, they can be added in animal feed to bind aflatoxins and thus prevent their absorption in the gastrointestinal tract of the livestock. These binders, they reduce aflatoxin ammonia levels in the milk produced by dairy animals consuming contaminated feed, thus minimizing the risk of aflatoxin entering the food chain, because they bind the aflatoxins in the gastrointestinal tract of the livestock, and the aflatoxin cannot go in the blood of the consuming animal. Regulatory and monetary measures have also been much important in management of aflatoxin incidences. Setting maximum residual limits, MRLs, governments and international bodies have set maximum allowable limits of aflatoxins in food and feed, and they vary by product type and by the region. Routine testing is also important, and routine testing has SPLC and ELISA and spectrophotometry that can detect various levels of small levels of aflatoxins in the food products or agricultural commodity. Traceability and certification is important because traceability systems, they allow for monitoring of aflatoxins levels across the food supply chain. Certification systems for aflatoxin free or low aflatoxin products may help ensure consumer confidence and compliance with international standards. International cooperation is also important because collaboration between governments, international organizations, and the private sector is critical to control the spread of aflatoxins, especially in regions where contamination is widespread. This includes sharing knowledge, providing training, and improving infrastructure for monitoring and management of aflatoxins over the globe. Education and awareness, training farmers and food producers for food safety concerns, post-harvest handling, and good agriculture practices. It's essential to reduce aflatoxin contamination. Programs aimed at education smallholder farmers and food processors, it can help reduce contamination risks in developing countries. Public awareness campaigns may be necessary to inform consumers about the dangers of aflatoxins and the consumption of aflatoxin contaminated foods and feed. So they may be encouraged for purchase of products that are from trusted sources that are free from aflatoxin contamination and may strictly adhere to safety standards for the sake of their own health and the health of their animals. Coming to future challenges and research, the final portion. Challenges in aflatoxin management is that both research and regulatory areas that need to be addressed to ensure food safety and minimize public health risks. These challenges are particularly important in developing countries where food safety standards, they are kept low so that the entire population can be fed, because ample food is not available to every person in such countries. The climate change and agricultural practices and limited resources, they have contributed to persistent aflatoxin contamination in food and feed. Research is the key to overcome these challenges, and new strategies are being explored to prevent, detect, and detoxify aflatoxins from food products. Climate change and environmental conditions, increased temperature and drought, expected to increase temperatures and alter rainfall patterns, particularly in tropical and subtropical regions, in which most of the developing countries and underdeveloped countries are fall. Particularly now, where aflatoxin producing fungi they are thriving, and drought conditions can increase plant stress, thus making crops more vulnerable to fungal infections, leading to higher aflatoxin contamination. Extreme weather events like flooding and heat waves, they can exacerbate the risk of fungal growth in crops, especially when these events occur during the pre-harvest or post-harvest stages. Farmers may have difficulty predicting or adapting to these changes, leading to higher contamination rates. In many regions, especially Sub-Saharan Africa, South Asia, and parts of Latin America, there is still a lack of awareness among smallholder farmers about the dangers of aflatoxin and production proper agriculture practices to prevent contamination. This lack of knowledge, it leads to poor crop management, insufficient post-harvest handling, and inadequate storage conditions. Training and awareness programs for farmers and food processors are often underfunded or poorly executed, and this limits the effectiveness of aflatoxin control measures. Poor storage facilities and limiting access to technology, it hinders effective post-harvest handling and storage of crops, allowing aflatoxins to develop during the storage phase. In many developing countries, traditional storage, for example, storage in mud huts and storage in jute sacks, it cannot provide the necessary protection from fungal contamination, because moisture from outside it can ingress to the stored product. Inadequate testing infrastructure in many regions hampers the ability to detect and monitor the levels of aflatoxin in food and feed. Costly testing measures such as SPSC, HPLC, and ELISA may not be accessible in low-resource countries, leading to undetected contamination food products. While some countries have stringent regulations like EU and Codex Alimentarius on aflatoxin limits, enforcement remains a significant challenge. Many low and middle income countries lack the capacity to monitor and enforce regulations effectively, leading to illegal trade of contaminated products. In global trade, differences in aflatoxin standards between countries can create trade barriers, limiting market access for aflatoxin contaminated products. There are research direction and future innovations. Research on aflatoxin is dynamic and rapidly evolving field that aims to understand, prevent, detect, and mitigate aflatoxin contamination. Future research efforts are focusing on innovative technologies, improved agriculture practices, better regulatory frameworks, and novel detoxification methods. Development of aflatoxin resistant crops is one of the most important factors, most important avenues or areas to be for research. Improved methods of detection of aflatoxin, even low amounts, is the need of the hour, and biocontrol and biological control agents may be explored for reducing the risks of aflatoxin in food and feed. Aflatoxin detoxification techniques like aflatoxin binders may be explored, and improved post-harvest management and storage solutions may be explored for reduction of aflatoxin contamination in the food and feed. Risk assessment and climate change modeling is important in long-term management of aflatoxin contamination over the globe. Policy and global collaboration is important. International collaboration among researchers, governments, and international organizations like FAO, WHO, and codex is essential to develop and harmonize aflatoxin management strategies. This includes coordinating risk assessment, sharing research findings, and supporting capacity building in developing countries. Stronger regulation and enforcement is also important because these mechanisms are important to ensure compliance with the aflatoxin limits of both domestic and international trade. Research into effective enforcement models will be essential to reduce aflatoxin contamination on a global scale. Coming to the takeaway message, while significant progress has been made in understanding and managing aflatoxin contamination, future challenges remain in the face of climate change, limited resources, and the complexity of agricultural systems in many regions. Research on genetically resistant crops, improved detection methods, biocontrol strategies, and innovative detoxification techniques will be crucial in addressing these challenges. Additionally, international collaboration and stronger regulatory frameworks are key to ensuring a safe and sustainable food supply. Ongoing investment in research, education, and technology will be essential to mitigate the public health risks posed by aflatoxins in the times to come. In the battle against aflatoxins, knowledge is our most powerful weapon. And we know that 56% of maize is contaminated by aflatoxin among all the cereals, and 55% of groundnut contaminated by aflatoxins among all the cereals, all the seeds. And it's time to address poor food handling practices to ensure safer food for all people and feed for animals. Aflatoxins are silent but dangerous intruders lurking in food, threatening human health by every bite taken. Addressing aflatoxin contamination requires a global approach as these invisible threats cross borders and cultures with quite ease. These are the people in our team, and now questions or comments, suggestions, they are welcome. Thank you.
Thank you so much, sir, for such an enriching session. Now, if anyone has any questions or doubts, they are welcome to unmute their mics to ask the question directly, or they can drop the same in the chat box. In the meantime, sir, I would request you to wait for 2 minutes as majority prefer to actually type in the chat box.
Yeah. There is a message in the chat box. We kindly request all the, okay, it's not for me.
Yes, I have question.
Yeah, please.
All right, sir. Good afternoon, Dr. Gerald, and every other person in the house. I am Ebe Kuma from Nigeria. You made mention of the use of chemical like fungi to preserve crops from aflatoxins attack. Then I'm asking like, what possibly will be the impact of using fungi in the preservation of crops, knowing that we sell these crops from one person to another hand to another hand to another hand?
I'm sorry, doctor, your voice is breaking. Could you please send your query in the chat box? I could
All
not.
right.
Okay.
Let me do that.
Sharing? Can I stop sharing now?
All
Yes,
right.
yes, sir.
Yes, sir.
Okay.
Sir, in the meantime, there are quite questions from our participants. From Mr. Vivesh, thank you so much, sir, for such an insightful session. As I am currently working on endophytic microbes, do certain chemicals naturally present in the crops either trigger or block the aspergillus from producing aflatoxins?
Pardon, the question, is it in the chat box?
Yes, yes, sir, it's in the chat box.
Question is differentiate between acute aflatoxicosis versus chronic. Acute aflatoxicosis. It's symptomatized by nausea, vomiting, abdominal pain, and sometimes death in acute. And in chronic aflatoxicosis, it's various kinds of symptoms, particularly nausea. It does not, although it does not result to death necessarily, but it can hamper the activities of our very vital organs. So it's equally important in long term. There is one. How can we know the levels of aflatoxin? There are measures, HPLC and ELISA. that can be used to detect levels of aflatoxins in any kind of agricultural produce, including milk and milk products. Okay, there is one question. Do certain chemicals naturally present in crops either trigger or block aspergillus from producing aflatoxins? No. There are certain resistant varieties which can, in fact, growth of aflatoxin, growth of aspergillus flavus is important to check for reduction of its capability of production of aflatoxin, because if it has grown, its aflatoxin producing capability cannot be challenged by any means. There is no chemical in plant or host that can reduce its capability, its physiology for producing the secondary metabolites. Growth, checking its growth is the only option that can lead to reduction in the amount of its production of aflatoxin or amount of aflatoxin that is produced. One more question. What is synergistic effect of aflatoxin with hepatitis B virus in liver cancer? Yeah, it has. The question is very good, and it's welcome now. The synergistic aflatoxin, it hampers the activities of liver, and liver already having stress from aflatoxin, it is very much readily become infected by this hepatitis B virus, because it is not completely healthy. So its defenses are already surrendered, and the synergistic effect of both is almost lethal in many cases. And although liver is one of the organs that can be that can regenerate itself, still it's important that when it is challenged by a number of factors, for example, someone has hepatitis B and he also consumes alcohol, and he has got aflatoxin in his diet. So the challenge is from three directions. So stress on the liver will be thrice as much as from one factor. Okay, so number of factors posing stress on functioning of liver, it may reduce the longevity of the person in the same level. Okay, so thank you very much. Okay, thank you.
There's just one more question from Ms. Ruchika. Are there any genetically resistant crop varieties that can reduce aflatoxin contamination?
No, not genetically modified varieties. No GM crops have been bred so far specifically for reducing aflatoxin contamination. However, there are crops that are resistant to many of the fungi, and when we plant these resistant plants or resistant varieties, they have less infestation of aflatoxin producing fungi, these Aspergillus flavus and Aspergillus parasiticus. And most importantly, equally important, is that management of insect pests in the field, because even the crop is resistant, infestation of aflatoxin producing fungi may not be direct, but when the grain is damaged or nut is damaged by any kind of insect, its outer wall, its skin is broken by any kind of insect. So physical boundaries or physical defenses are compromised, and they can form excellent entry points for the fungi that can later produce aflatoxins, and that cannot be prevented by any means. So breeding for resistance is equally important, and IPM, good practices of integrated pest management, it can also have equal importance. Okay.
Thank you so much, sir. That concludes our Q&A session. Now we will conclude our Zoom meeting. So as we come to the end of today's session, I would like to express my heartfelt gratitude to our esteemed speaker, Dr. Jay Prakash Rai, sir, for sharing his valuable knowledge and insights with us. Thank you so much, sir. Your lecture has been both enlightening and inspiring. The depth of your experience, coupled with your dedication to research and agriculture development, has provided us with valuable perspectives that will undoubtedly benefit all of us in our academic and professional journeys. We are truly grateful that you took the time to interact with us and share your expertise, sir. On behalf of the organizing team and all the participants, I extend a sincere appreciation for your presence and making this session so engaging and enriching. We also thank all our participants for their active presence and enthusiastic participation throughout the session. With this, we conclude today's program. We hope to see you again in our future sessions. Thank you, everyone, and have a wonderful evening ahead. Thank you so much, sir.
Thank you. Thank you, organizers,
Thank
for
you.
providing me
Thank you
this
so much, sir.
opportunity to be with the audience. Thank you very much.
Thank you, sir. Now we concluded our session. Everyone is free to leave the Zoom meeting.